Manas will be joining.
And Dr. Enan Mondal. I spoke to Gupta. Gupta is joining.
Manas will be joining.
So I have started the live streaming and sending this link to everyone in the chat of Zoom. And Amitabh,
me also.
Amitabh, I have sent it to WhatsApp. So if you want, you
Yeah,
can.
I got it.
Yeah, okay.
Thank you.
Amit, please send it to me also.
Okay.
WhatsApp.
Amit, it is still showing you are in webinar. Still showing.
I will now start the webinar and allow all the attendees to join, and we'll wait for 3 minutes before starting the webinar.
Yes, please allow.
Yes, yes. $300 registered.
4 p.m. Let's start then.
Shall we start?
Just let's wait for another 1 minute. It's
Why?
3:59. 3:59.
Who?
3:59. 1 minute we should wait. Good afternoon, everybody. On my personal behalf and on behalf of GBS Energy Private Limited, I welcome you all in this seminar. This seminar is fifth in series from GBS Energy Private Limited, and we have organized 4 such seminars during the pandemic period, and before that we had conducted seminars in different hotels, in physical mode. Right now, I start the seminar, and I now hand over to Mr. Niranjan Saha for his welcome speech. Mr. Saha, please.
Good afternoon, all. On behalf of GBS Energy Private Limited, we welcome all the panelists and attendees in this webinar organized by our company. GBS Energy Private Limited was established in April 2017. This company is a knowledge-based organization rooted by professional engineers having long years of experience with proven track record in power sectors like thermal, hydel, solar, biomass, etc., and also in other core engineering sectors like steel, material handling, maritime, etc. GBS has also close association with reputed Indian and global EPC companies. Our business areas are in subcritical, supercritical, and FGD in thermal power area, small, medium, and mega size hydro projects, solar power plants, biomass plants, cogen from sugar mill and rice mill, and also in waste management projects. GBS also is in a position to support in development projects and products in core sectors areas and also in other areas like material handling and heavy engineering equipment. Our company is also organizing seminars on different subjects for interacting and sharing knowledge among various industry personnel, government functionaries, and research and academia from India in the field of conventional, non-conventional power, and also from other core sectors areas like steel, mining, etc. During COVID-19 situation, we organized 4 webinars. The first one was on 6th November, and the topic was renewable captive power plant at cost-effective rate for steel, foundry, and other heavy engineering industry. Second one, we organized on 22nd of January 21 on the subject of innovative approach to increase use of steel in building, bridges, flyovers, and other infrastructural areas in a cost-effective manner. Third one, we organized on 1st August 2021 on reverse engineering in industries for hardware and software, a facilitator for Atmanirbhar Bharat, particularly in COVID situation. Fourth one, we organized on 12th December 2021 on role of design engineering and technology for overall socio-economic development to upgrade India to a new height. Today, we have organized our 5th webinar, and the subject of our today's webinar is use of steel in structure work for industries, infrastructures by optimization of weight and allied parameters with cost-effective application and solution. We all know that the steel plays a vital role in construction of any infrastructural project like thermal power, hydel power, and also in heavy industries, bridges, flyovers, buildings, etc. The quantity of steel vis-a-vis the total cost of steel share a major role of the project's cost. Steel prices in India have a steep rise ranging from 20 to 25% since August 21. And this trend is still continuing. As a result, the ongoing project costs have increased considerably. Moreover, the upcoming future projects cost will also increase. So the object of our today's webinar is that with this abrupt and steep increase in the prices of the steel in recent past, it has become necessary for the designers, users, and the contractors to optimize steel usage, but without compromising the safety design parameters and also the seismic zone factors of the project site. We have with us some expert panelists who, with their long experience and their knowledge in design and engineering in this field, can share their views and opinion on this subject through their lectures and presentation in this webinar. Thank you all. And now I hand over to my colleague Amitabh Ghosh, the Director GBS Energy Limited, to say a few words about this seminar. Thank you again. Mr. Amitabh Ghosh.
Thank you, Niranjan. Good afternoon to everybody. Again, on behalf of GBS Energy Private Limited, we welcome you all on this online engineering seminar. My colleague Mr. Shah has told about details of our company. I'll now directly come to the subject. The subject is use of steel in steelwork for industries and infrastructure, optimization of weight and allied parameters with cost-effective application and solution. Now, this subject we chose because we thought that this subject is very much relevant in today's context, particularly from the point of view of post-pandemic situation and also against spiraling increase of steel price. We have seen that following this approach, we will be in a position to save huge amount of exchange money. Against a reduction of near 5% steel weight, the yearly saving in India could be in the tune of 50,000 crore. You know. I'll come to that in the details later. And this is possible within the ambit of the technocrats. But we know some more about him. Mr. Balraj Joshi was CMD in NHPC, the biggest hydropower and renewable energy mini Ratna public sector. He had a checkered career of around 4 decades in NHPC for various mega hydro projects in India and abroad, out of which a long period was in design and engineering, which is relevant here. He was also involved in a project in West Bengal, project management and design consultancy for Bokreshwar Dam project under WBPDCL. I had the opportunity of working with together in various NHPC projects. Post-retirement, he is now holding a very responsible and prestigious position. He is technical member of NCLT, National Company Law Tribunal at Kolkata. Incidentally, NCLT is a quasi-judicial body in India formed few years back by Government of India that adjudicates issues relating to Indian companies like insolvency, winding up, etc. We are really happy and pleased to have his participation in our seminar. Over to Mr. Joshi.
Thank you, Amitabh, and thank you, everybody. Good afternoon. And it's really a happy situation for me to be addressing a technical seminar after quite some time, because as Mr. Amitabh Ghosh just now said, that I am now looking after a tribunal. It's a company tribunal. So it's a totally different work. It's called technical member, but it actually in the real sense means everything other than judicial. So it contains accounts and corporate governance and things like that. So it's not exactly the technical as we understand in the real engineering sense. No doubt the knowledge which we have gained, the experience which we have accumulated over all these decades, it comes handy. But all the same, I'm very happy that now I've been asked to speak on something which is really technical. And when Mr. Amitabh Ghosh asked me that whether I'll be able to speak on this, I could not say no for two reasons. One, of course, is that Mr. Amitabh Ghosh has been such an old, old horse out of the hydro sector that he is actually revered in the NHPC circles like anything. So this was not possible for me to say no. And second, he told me that officers from WBPDCL are also coming. And when he named Mr. Mahapatra and Mr. Niranjan Shah, that was another reason I said I would certainly like to come. After about 23 years, we'll be meeting them. And that was another reason why I could not say no, and I had to say yes to this. I was in Bokreshwar project from somewhere in 1997 and to 1999. So we saw completion of that dam.
Yeah,
Mr. Mahapatra can really tell how best we were able to perform those functions which were expected of me. But I think we did.
Absolutely.
As far as I'm concerned, I think I gained a lot of, the professional working under Mr. Mahapatra. We saw his school, how he used to handle the matters, difficult matters. And really, I'm enriched after working with you, sir. Thank you so much. So the topic which is being given to us today is that optimization of steel in the industry and infrastructure works. Well, I think what Mr. Ghosh had in mind at that time, because he is an expert in the hydromechanical equipment, design and engineering and planning and construction, you name it. And he is master of everything as far as the HM parts are concerned. And hydromechanical parts, they play a very important role in the hydropower sector because we eventually have to have a dam and penstocks and powerhouses, which consumes a lot of steel. And he's not wrong in saying that even if we are able to save 5% of that steel, it would amount to something like 50,000 crores. It might be more. The whole issue is that the design and engineering, basically, it starts with optimization. Optimization is a very essential part of the design, and eventually every designer tries his best to estimate the forces which are going to come on the structure and then provide equivalent and good material for that so that these stresses can be resisted and taken on with whatever calculated formations are allowed as per our codes. And talking of the Indian codes, when I discussed this matter with Mr. Ghosh, we were also on the same page that Indian standards are basically very conservative. This being the scenario, eventually you are following those codes and in the process utilizing probably much wider, much larger amount of steel, which is actually required. I agree with him on this observation of his. Slight variations, which I might now like to come upon, particularly specific to hydro sector. Now, when I say hydro sector, I mean the large, generally medium to large hydroelectric projects employing large amounts of concrete, steel, and cement. Roughly put, it's more than, let's say, 250 megawatt and above projects. Below that, I didn't have much let's say experience or occasion to work on. So they were very large projects. Now, 2 or 3 things have to be spoken about here. One, Mr. Niranjan Saha referred to as seismic factors. Now, seismic factors, they have evolved over the period of time. And with each passing day, we are becoming wiser and we are increasing the seismic factors. We had a real predicament in one of our projects, which is in Assam. It's called Subansiri project. You must have heard of. This is the largest hydroelectric project of the country, going to be. This is under construction. It is 2,000 megawatts. From thermal standards, it may not appear to be very large one, but from hydro standards, this is pretty large, installed capacity of 2,000 megawatts. And the crux of the matter is that the dam is spawning 2 states. One bank is the Arunachal Pradesh and second is Assam. And the submergence of that particular project was mostly in Arunachal Pradesh. So as per the agreed formula, most of the benefits also go to Arunachal Pradesh. And this was the bone of contention with Assam, that why should we not get the benefits of the project and let's say the share of the developmental pie. Because they say we are the people who are sitting on the downstream side, and in the event of any dam failure or any such event, or maybe misoperation of the gates, it's only the Assam people who are going to get bear the brunt of the situation. So therefore, we should be getting more developmental pie. Now, that was a predicament, and finally the project was stalled because of the political interventions, and for 8 years, 8 long years, this remained stalled. Now, finally, we have been able to bring it up. One of the chief objections taken was the seismic factor. Of course, the people who were protesting, they didn't understand that, but the people who are fueling such agitations, they said the seismic factor is too low, and therefore the dam is not safe. Even the gates which are being provided here are designed for only 0.38 G, which is lower value. It should have been taken at least 0.5 G. Eventually, the requirement and the protest went to that situation that they said the protesters wanted that now this matter be referred to an international body. But in the meantime, since NSPC had already constructed half of the project and sunk some 10,000 crores of rupees And that was the time when I was at the helm of affairs. I became chairman at that time. It was a very difficult situation. What to do? If you today say that the seismic factor is revised, what happens to the structure which is already constructed? 50% of it is already constructed. And to our mind, the factor which was taken already, it was quite high and it was approved by all the statutory bodies of Government of India. So therefore, absolutely, there was no reason for us to budge and say that, okay, we are going to revise the seismic factor just because we have spent 10,000 crores of rupees. And had we actually agreed to that, probably we would have really set a very bad example for all new projects to come on. So therefore, we stood our ground, and finally, the matter went to NGT. It was fought at various levels, social, political, and technical. And finally, NGT cleared it in 2019 October, and we started the construction of the project at that time. Now, Mr. Amitabh Ghosh told me that the dam also has quite come up to a certain level, and the gates are being erected. Now, talking of Subansiri gates, these gates are very special because probably this is for the first time that such large gates are being placed at such a big head. Eventually, the requirement of steel becomes very high. Coupled with that is the seismic factor. And let me also share with you today that in order to satisfy and also ward off a conditions that if the matter is referred to an international panel, we shouldn't be caught unaware. So we had checked the entire design for 0.5G also by increasing the 33.5% stresses, which is allowed as per the BIS codes. So the dam is pretty safe and the structures are safe for 0.5G also, that we have checked. But the point is that any optimization in such a situation probably would be seen as if we are playing with the safety of the structure. So this is one aspect which has to be kept in mind. Incidentally, at the similar time, I had a chance to go to Canada where we were participating in the I-Code seminar, which is held annually. There I had a chance to meet with the members of the seismic committee on the large dams. And the murmur there was that, yes, we also agree with you, but probably you could have taken 0.6G. So now with such kind of uncertainties, how much optimization can you try? This is one of the aspects which needs to be considered. So when the forces are uncertain, when the forces are such that probably there's not even a consensus internationally on these forces and the amount and magnitude of these forces, whether should we risk some kind of optimization, because even though it may not be technically impossible or technically acceptable too, but socially and politically will it be acceptable to us? That is one factor. I just want to leave this thought with you. And secondly, in the civil construction of hydro projects I've seen, let's talk of underground structure where steel ribs are utilized in the tunnels. Generally, the design section which stands all these rock loads is ISHB 200. Now, ISHB 200 is generally not manufactured by the steel manufacturers because it is a special section, so it has to be specially ordered. And by the time you give an order and the material is brought by them and rolled over, by this time the construction at site has picked up and people say, please find a substitute. And the substitute, nearest substitute which is there, it comes to be ISMB 250. But in the process, even though the ZYY, Z-axis is matching, but the weight of that section is more. Now, the availability is governing basically, are you able to optimize or not? And I have been in discussion with SAIL, with Rathi, with everybody saying that, no, sir, this steel we are not rolling because the utility is not very high. So therefore, the consumption is not very high of this section. We are not rolling this section. So this is another aspect I want to say, that as far as the saving of steel is concerned, the availability also comes, one question comes that whether it's available or not. Another example of use of larger amount of quantity of steel is in the TOR steel, the reinforcing steel. More often than not, there are contractors' claims that we have placed more. Explain that if you are specifying a 32 mm diameter steel and it is paid on a nominal basis, which is the standard rate given by BIS multiplied by the length you have placed. That is the amount of the money which you pay to the contractor. But contractor says, no, sir, the actual per meter weight of this particular steel was much higher. The reason being the die through which this cold bars or CT bars are produced, that becomes enlarged in size. So 32 mm diameter bar is not exactly 32, but it is maybe 34, 35. And we actually had measured the weights of this particular bars, and we found that this is true. That over a period of time, the die certainly becomes slightly larger, and the amount of steel which is actually put inside is more in weight as far as the weight is concerned. So this is another important area where something needs to be done. Maybe metallurgy of dies need to be improved so that over a period of time, the diameter of the steel doesn't increase by itself. If it's a 32 mm diameter steel, it should remain 32. About earthquake, I've already spoken. And the third factor, which is now becoming of a very great importance, and to my mind, that's a very personal view of mine, that the climate change aspect, which is being blown over, probably is not very well understood. We are saying that maybe larger floods are going to come. Maybe that's why you please provide more steel. So this is an aspect where the climatologists are also, let's say, putting some kind of skepticism in our minds that are we really doing something which is really safe or not? Let me give an example of Tista 5 Dam in Sikkim. This is a dam which we had designed in 2000-2001. When the construction started, there was a pier which developed a crack. Immediately the bells started ringing, and they said, this is such a large dam, it's about 110 meters high. This pier, the first pier which you have cast, is cracking now. Are you safe? Is your foundation really checked? Whether this is stable or not, and whether earthquake parameters have been taken or not. So there was a committee formed. And the technical committee went into all the kinds of discussions, and finally they said, they checked, have you provided the required quantity of steel or not, which is given by BIS. And when we said, okay, yes, we have provided, and they checked from the design that yes, that was the quantity which is recommended by BIS also. So they said everything is okay now. So that means steel becomes a major casualty when the safety comes. So a designer is always scared in his mind that if I provide a lesser steel tomorrow, I might be caught, for the simple reason that the forces which are coming on are probably not very exactly calculable. So this is another aspect which I want to put forward here. And another complication which has been presented to us is the use of high-end computers for simple works. Now, high-end computers of the 3D dynamic analysis, they present so gory pictures of, the deformations taking place everywhere. And I'm not saying they are wrong, but probably they should be applied only where they are actually required to be done. They are very merrily used in the underground structures, and they really present something of a grave concern. They say everything is going to collapse. So at the end of the analysis, the designer thinks, why should I take it over on myself? If 32 mm diameter anchor is sufficient, I'll provide 36 mm diameter. So he goes for that. So I fully agree with Mr. Amitav Ghosh when he said that no policy changes are required, only technocrats can do it. And I completely agree with him. We have to really fine-tune our engineering proficiency and our engineering sense and knowledge. And such seminars, I would say, go a long way in really iterating ourselves, reiterating ourselves, and again iterating ourselves, that whether what we are doing is correct or something more can be done in an engineering sense of the word. So with these thoughts, I will once again thank you, Mr. Amitav Ghosh, and all the attendees for their valuable time. Thank you so much. Namaskar.
Thank you, Mr. Joshi, for your very valuable speech from design aspect. It's really useful for the designers, and they will be able to learn many things out of it.
Thank you.
For the time being, I hand over the session to Amit again, just to say something to the audience and to the speakers.
Yeah, thank you, Mr. Arnab. It gives me immense pleasure to host this webinar. And I welcome everyone in this webinar, and like to congratulate everyone here. We have crossed 300, more than 300 participants in this webinar, and a big congratulations to everyone. About the guidelines, I will quickly mention a few of things which we should adhere to. For the panelists, like from now onwards, we will be allocating like 7 minutes for each panelist. And to enforce this, I will just ring a buzzer if it is nearing about 7 minutes, and would request every panelist to kindly mute themselves to prevent any external noise while someone is presenting or speaking during this webinar. For the attendees, if you have any questions, kindly you can raise these questions through Q&A section. You can find that Q&A button at the bottom of your Zoom. Or in case you have any other questions, we will open the floor once every panelist have spoken, so that you can directly ask your favorite panelist about your questions. This webinar is also streamed live in YouTube. So in case if someone of your members are unable to join this Zoom webinar due to any technical issues, they can follow the link given in the presentation, or I've also shared this same link in the chat. You can share with them, they can view these things in YouTube as well. And I will now, without wasting any more time, I will hand over it to Mr. Arnab to follow the presentation now.
Thanks, Amit. Thanks, Amit. I now request Mr. S. Mahapatro, ex-Managing Director of WBPDCL, to start his speech. Over to Mr. Mahapatro.
Good afternoon to all of you. But before saying something, let me convey my heartfelt congratulations and thanks to Mr. Joshi, because when he was mentioning the old days at Bakrishwar, I became a little emotional, and I revisited the days just 25 years down the lane. And really, it was, Mr. Joshi, I tell you that, it's so very nice to see your face here. I have so many officers I have seen in my career, service career. But you are one of the most, let me mention it for record also, that he is one of the most efficient, dynamic, and sincere officers I have met so far. In my 40 years, service with WBPDCL. Thank you, Mr. Joshi. Okay, as regards today's seminar, Amit, you'll be sharing my PPT. Okay, thank you. So please look at the screen. Actually, my presentation is very brief. It's only 7-8 minutes.
Yes, I will share your screen.
Yes. So today's seminar topic is already mentioned earlier. So now, as regards the role and importance of steel, it would not be an overstatement to say that the steel industry has always been at the forefront of industrial development and forms the backbone of any economy. Steel is said to be the wheel of the moving world, being the most important driving force for prosperity and welfare of mankind in this sustainable society. But the worry is that the price of steel is rising very fast worldwide. Prior to outbreak of COVID-19, the rise in steel price was there, of course, but it was steady. And it could have been predicted also. It was very much predicted. But there has been unprecedented price hike of steel during last 2 years pandemic regime. In certain countries, steel price had jumped to 200%. And hot rolled coil touched a record level of 300% increase. And as already been mentioned by some of the speakers, that in Indian market, sections and bars have increased by more than 25%, and increase of HRC is around 30%. So let's see what sort of influence it's having on the projects and all that. And what is the way out? That is also we can discuss. About 60% of the steel consumption is accounted for by infrastructure and construction segments. There are a lot of projects in the pipeline that are expected to take off very early. Obviously, such unpredictable rising steel price will adversely hit these projects because of risk factor and price escalation and all that. There comes the need of taking appropriate measures to reduce the manufacturing cost, which may partly offset the pressure of abnormal pricing. So we can discuss what are the aspects which have some contribution to bring down the manufacturing costs. Production costs. No, please, next one. Yeah, influence. Okay. Trend of rising price in the industry. No, next. Next one. Yeah. Different aspects of cost optimization of manufacturing. Production costs are contingent to various factors, and finding the right ones for application of cost cutting without damaging the product quality or business reputation is the desired methodology to reduce the cost. Let's discuss some of these aspects. Design and engineering. Design phase contributing significantly to the overall cost of the product. Optimization needs to be focused on engineering analysis, concept design, architectural design, and detail engineering. So as regards engineering activities, the using proper part tolerance. Tolerance is the degree to which its exact dimensions can vary. The optimization of tolerances saves material and reduces cost. Another is using hollow structure. Using a hollow structure, adopting use of structural elements such as ribs, gussets, provide significant strength to the thin-walled pipes, thin-walled parts. So naturally, that will save a lot of material also, and thereby reducing the cost. As regards manufacturing process, we know that process optimization is to reduce the eliminate. Next one, next. Yeah, process one. It will reduce or eliminate time and resource wastage, unnecessary costs, bottlenecks, and mistakes while achieving the process objective. Minimizing setup. Setup or fixturing or tooling is the process of physically flipping a part during the building process. Optimization of this part of production process ensures minimal flipping and reorientation during machining, which saves time and cost also. Now another very interesting is the next one. No, okay. No, earlier one. Yeah. That's right. Model based.
I'm in slide number 5. You want me to go slide number 6, earlier one, or 4?
No, this one. It's okay. Fine.
Okay.
Model-based engineering and manufacturing process to reduce manufacturing time and cost has generated tremendous buzz within the manufacturing industry. Model-based engineering is a new concept. It's not a new one now. It has already been being used for a pretty long time elsewhere. So actually, that the concept is to use the visuals of models for designing for expressing design information, for developing a product, or to particulate processes and all that, and even to simulate the real behavior of the object. And you can update also a lot of things. So instead of keeping a hardware as you used to do earlier, keeping a hardware or some digital documents, everything can be done by a master model. That will save a lot of time, and so the cost reduction will be also. Next. In addition to process and manufacturing, design and engineering, there are some other allied activities also in a steel plant, which can also be considered suitably for the purpose of reducing the manufacturing cost. One vital aspect is recycling and reuse of byproducts. So within the steel production cycle, several products like slag, sludges, scales, dust, etc., are produced, some of which are directly suitable for internal reuse, and other ones can be separated in a fragmented way for external use. And energy auditing and optimization of energy consumption. The steel manufacturing processes are highly energy intensive. Share of energy cost in the total cost of production is quite substantial. So controlling energy consumption through carrying out the energy audit shall enable reduction of production cost substantially, maximizing the quality control. Main goals of quality control are to ensure customer satisfaction by delivering defect-free products and radical reduction of defect rates in the production. Controlled technological processes are the most important way to reach these goals, and by way of that, we can also save a lot of cost in the manufacturing cost also. Particularly, we can reduce the quality cost. Otherwise, same thing you have to do it again. Exercising health and safety norms. Because of complicated equipment layout and hazardous processes in steel plants, the health, safety, and production of the employees, equipment, and environment is very crucial and critical, since it affects both economic and social factors. Regular employees training, strict observance of safety norms by the employees, deep management involvement, and exercising safe working practices will reduce downtime, resulting in substantial reduction in the cost of production. And lastly, regarding price reduction options, we know that in order to bring down the overall steel manufacturing cost, choice is usually either of the two options, either cost cutting or cost optimization. As regards cost cutting, typically cost cutting programs deliver short-term tactical gains. It's an one-time operation. Whereas the cost optimization entails a systematic and sustainable method to manage priority costs, to ensure that operational capabilities of various functions are not affected. To conclude, cost optimization is a very efficient tool for managing the production cost, ensuring effective demand management, and better skill management, and better product quality. With those few words, I conclude my presentation. So thank you very much. Thank you all the audience for patiently. Thank you.
Thank you, Mr. Mahapatra, for your very interesting lecture and a definite guideline for cost cutting. It will definitely help if people follows it. Now, our next speaker is Mr. BP Sarkar. Mr. Sarkar is from, he worked in Tata Steel throughout his career, and now he was a founder member of a technical journal called Steel Tech, which is very renowned journal in the field of steel industries. I also help him to some extent. Now Mr. Pritish Sen is looking after as editor of that Steel Tech. Mr. Sarkar is the next speaker. Please carry on, Mr. Sarkar. Please take over.
Am I audible?
Yes, you are very much audible. So please continue.
Thank you. Very good afternoon to all the participants, panelists who are here. Thanks to Amitav Ghosh and other organizers to choose this important subject of optimization in the design, save steel, and reduce cost. Especially it is important that steel prices have gone up from 40,000 to around 75,000 per ton now. My previous speakers have covered very well about the design aspects and other various factors connected to steel. As you know, steel is a very important material. It is abundantly available at economic cost. In fact, the per capita consumption of steel is taken as the index of development of the country. And like China and others, India is also trying to achieve much higher per capita consumption from 74 kg. World average is 225 kg. So we must see that the steel is used in more construction and other areas. Steel gives strength, higher life, and especially in buildings, if steel is used, we can get better life and also better carpet area compared to ordinary traditional concrete structure. I'll just point out a few points for designers and steel procurement people, which I've got my experience working in marketing and purchase of Tata Steel. During steel procurement, one need to find out the proper source. You'll find that the secondary steel producers, mainly their tolerances are on the positive side. Suppose it's 8 mm rebar, it will be mostly found 8.1, and since it is, has been pointed out, it is used in length-wise. So we use more steel for the same job if we take higher positive tolerance. Whereas in the integrated steel plants, the tolerances are better controlled within minus plus tolerances, and it is normally expected that steel products from integrated steel producers will have better tolerance, and subsequently and consequently it will give you better saving in steel. In steel procurement, the steel purchaser should see that the design sections, what they have been designed, the steel procurement should see that they can get that design, both for long and flat products. For flat products, suppose you require 4.9 or 4.95 millimeter thickness, the steel producers will normally say that we give only standard sizes. BIS is also very conservative in our country. Now, the steel producers will try to give in standard sizes. So if you require 4.9 or 4.95 thick, they will give you 5 millimeter. So you have to use 5 millimeter, and consequently you are using more steel. But with all this steel production is improved in India, there are more steel producers in the country. Maybe that you can choose proper supplier who can give to your need. In this example, 4.95, we can supply 4.95 as per the design, then you go for 4.95 and not 5 millimeter. Similarly, there is a scope that in the long products, especially the structural, they will always give as per the BIS design. But if the designer feels that the either wave or flanges can be different, maybe availability initially it may look difficult. But if the tonnage is high, then you can force to get your structurals as per your design, as per your flange and web sizes. And with that, you can reduce the steel's total steel tonnage required for a project. We have seen in Tata Steel, once we had to supply to French design to Italy, to Iran. And we have supplied to that design, some INP, something like that. So if the quantity is high, it is possible for steel makers to design accordingly to their roles and supply. Another area is use of high tensile material. In case of automotive design, we are using high tensile, all of us know, and we are saving steel. Whereas it's very popular in the automotive industry to use high tensile, but in other ordinary designs, we are not using, mainly because of low availability. Again, we'll have to, if the tonnage is high, and try to force these suppliers to give us to high tensile materials, structurals, or even otherwise rounds or TMT bar. So use of high tensile material always helps. Steel has, we have told that it's very important material, but it has got high density and poor corrosion resistance. So it is always preferable to use coated products like epoxy coating or maybe galvanized, color coated, etc. In case of TMT bar, in many areas, people are using epoxy coated bar or other galvanized also been tried. And especially in areas where corrosion is high, near the shore areas, one should use coated material rather than ordinary TMT bar. Stainless steel can be used wherever it is justified cost-wise, and naturally it will give much higher result. Due to high density of steel, replacements are taking place. We have already seen that the light materials like aluminum, PVC, FRP, etc., are taking place, are increasingly replacing use of steel. In fact, Tata Steel has made out a different sections making composite material and FRP material, which is called New Material Division, and it is headed by one of the senior most material person, Vice President, who is working in charge of quality control, and they're using FRP in many areas where earlier steel was being used. So it is a new area where steel can be replaced by FRP, which will make it the structure lighter and also cost effective. So steel producers have to see that how can they make it as per and supply as per the design use, and also supply the high tensile material if it is required by the designers. So this is what I want to say, and thank you for the opportunity to give me this. Thank you.
Thank you, Mr. Sarkar. Our next speaker is Director, GBS Energy Private Limited, Mr. Amitabh Ghosh. Mr. Ghosh, please take over.
Just to unmute. It's muted.
Mr. Ghosh.
Yeah.
Now you are unmuted. Yeah, you can start.
Mr. Amit, slide please.
Yes, I'm continuing with the slide. Able to view?
Yeah, this is the subject. We go to the next. Yeah. This matter I told earlier that this is the first thing which came to our mind, that India is producing 110 million ton per year, and if we take around 60 rupees a kg or 60,000 rupees per ton, then the value works out to be 6.6 lakh crore, and 5% of that is 33,000 crore. This is material cost. Plus fabrication, transportation, and erection, totaling it will be around 50,000 crore. So main thing is 5% saving in steel weight. A rough saving in a year is around 50,000 crore. We go to the next slide. Amit. So what is the objectives of this weight optimization? First, of course, saving against spiraling steel price increase, which the other speakers have told. And next is achievable savings of huge amount of exchequer's money, which otherwise is overspent for various reasons. The third point is enhancing steel uses and consumption through weight optimization without compromising on the safety parameters. Next is for implementing these objectives, we don't need any imported technology or equipment. No policy change is required. Saving can be done by technocrats. In fact, 5% saving, everybody will agree. It is not, I mean, you can do it very easily. I'll show you how. Next slide, please, Amit. Next slide. Yeah. So I'll give you the factors governing cost-effective, economical, and safe design of steelwork. How do we design this? The first point is concept. You know, if we change the concept, we can do some savings. Like two isolated tall buildings, if we connect on the top, the weight goes down. Or, you know, the modern power plant where chimney and then cooling tower and FGT is in the same place. See, with a change in the layout and the concept, we can reduce the load. Next is the loadings. We consider loadings, and sometimes we consider more because we do not know. So, you know, that way, if we know the level of loadings properly, then we can make it optimization. I'll give an example. I have seen a container crane. The design is based on the value that container is 75 to 80% is loaded. Because they have done the research that all over the world, container is never 100% loaded. And if sometimes it is loaded, then that motor or the structure can take that overload. This is how they are doing the optimization. Next is method of calculation. Method of calculation, we can do it either by manual earlier days, and now, of course, with the software, we do a good calculation, and then we save, of course. Next is stress level and safety factor. There is a permissible stress, and the stress level we can go up to theoretically 9%. But usually, and next is the choice of material. You can do, you know, any material, stainless steel or other material or high tensile steel, and we can save. And next is also choice of section, whether it is roll section or plated section, you can do the permutation combination. And finally, the most important is the feel factor. The designer's feel factor is very important, that what should you do? It is beyond calculation, whether this is okay or this is not okay. And this comes with the long years of experience with proven track records. I mean, like old doctors who are telling without investigations, they could do a lot of things. That is very much required to have the feel of the whole thing, you know, to make it economic. We go to the next, Amit. So, benchmarking in the international standards and best practices being adopted by technological superior countries. Generally, Indian codes are very conservative and results in 10 to 15% more weight compared to international standards. I mean, I have listened to this when I used to go abroad. Those people used to say that now the BIS code, now recently they are adopting limit state design, which is likely to have some positive effect on economy. Next, okay. So what do we do? I think whether the weight is more or less, one should see through weight audit and compare and explore not 5% saving in weight through weight optimization, which is nothing. Technical institution like IIT may be associated. Next.
Yes.
Next, Amit. Amit. Next
I'm in
slide.
slide number 7.
Next slide. Yeah. Now I'll come to a very important point. First of all, I'll come before that for critical applications, weight reduction should not go for them. But we know this is the field factor of the designer, that we know this is the area where we can try and we can do it. And believe me, there is no weight optimization, no expiry date for optimization, weight optimization. I can give you one example. In Purulia pump storage project, for some, that is WBACDCL, they could not give the site for 1 year. And that 1 year, the hydromechanical company Mitsubishi, they did work and utilized the time. And most important is that the next point, the last point I want to say, that there should be the mindset towards designers are required to be very positive and supportive, like developed countries. Then only we can achieve all these steelwork savings. In our country, the designers are not having a good position, unlike foreign countries and China. And number of designers are also very less. And thirdly, there is no incentive for the designers for weight optimization. So why you should do that? And last point I should say is the people who will not be in favor of this. One is consultant. Probably get more money out of the more project cost. So they will always increase. Number two, I will come steel users or steel producers. They might be thinking that their steel sale will be less. It is not true. If you see any retail market, every day they are giving discount. But overall sale is more. I think if your steel price level is less, then there will be more use of steel, which we want. So with that, I'd like to thank everybody. And next point, we can go next speaker.
Thank you, Mr. Bush. It's very crisp and useful. Definitely the people will be making use of it. Our next speaker is Mr. Suresh Kumar Gupta, MD, Crane Manufacturing India Private Limited and Crane Solar. Mr. Gupta, are you there? Please take over.
Yes, I'm there. Can you hear me?
Yeah, we can hear you.
Good afternoon, everybody. To start with, I introduce myself, S.K. Gupta from Crane Manufacturing India Private Limited, Mumbai. First of all, let me appreciate for the effort taken by my friend, Mr. Amitabh Ghosh, one time my colleague in Garlic Engineering, Mumbai. We were together for last 43 years. We are in touch with each other and good friend today. Let me tell you something about my company. I started my company in 1990 with just a mere order of 15,000 one-job spares of the crane. Later on, we go on growing, and today we have 2 units, almost 60,000 square feet, and manufacturing UOT crane, minimum 5 to 6 cranes per month, which roughly it is 220 lakhs per month. That is our monthly production. Friends, as it is said, necessity is the mother of invention. But today it is innovation, not only invention, it is innovation. If you have to survive, you have to implement latest innovative ideas. Otherwise, it is very difficult looking to the present market, especially steel, which is there's no end for increasing the price of this. So as all my friends aware, our country, rather whole world has suffered due to COVID-19. Due to COVID-19, the prices of all inputs, raw material have gone up by 10 to 15% in last 2 years. After COVID-19, today again we are seeing Russia-Ukraine war. Due to this, again the cost of steel went up by 25 to 30%. So in short, almost in 2 years, the cost steel has gone 40 to 45%. We have presently monthly consumption of steel around 80 ton, and we have paid almost 68 to 70 lakhs extra on buying the steel last year. So you can understand what is the effect of cost of steel going up in the market. Now, how to survive? Having more than 60 cranes in hand, if worth 25 crore, if we have to survive under the circumstances, we started working on following areas. That is number one, to reduce fabrication wastage. As per general practice, it is approximately 3%. By doing value engineering, proper layout, ordering right size of material, we could achieve to come down to almost 0.45%. That is net saving was about 2.5% on the only fabrication and wastage on fabrication. Can you hear me? Some problem? Hello? Hello?
Yeah, yes, we can hear you.
Okay. Next one is to increase the productivity by getting automation of cutting, welding, using CO2 welding, and latest product which we can use by, and this is not only saving money, it is a quality also when you use automatic CO2 machines. Number three, provide incentive to technicians on better product for better productivity. Because today I am in private sector and see that if I spend 100 rupees extra on my workforce, I get 10,000 rupees. That is my mantra. I take care of my all technicians, especially expert on welding, gas cutting, and marking cutting. The mystery is a very important one. But this was not enough for me to survive. Once again, my Bajrang Bali Hanuman in the form of Amitabh Ghosh, who came with a concept of reverse engineering. We two old men having experience of more than 50 years in the industry started working and gone to micro calculations. That is analyzing the actual weight versus theoretical weight, plus some more technique as per our experience, so that the viability or the survival is possible. And in the last quarter, I can only tell you, we could save more than 15 ton steel. That is about 7 to 8%. This is possible due to efficient and experienced designer. I can understand that my previous speakers have very wide knowledge. They are all top classes. But I personally feel when the engineer, you are running an engineering industry, designer plays a very, very big role. And that I can see here. I myself a designer, and I could produce this much of advantage by doing the value engineering and that. Now, next stage for us is to develop software on the basis of parameter already tried out. You know what is happening in the market. There are a lot of software coming for the various designs and other things. But what happens? They are not aware of practical things. That how much the price is increases steel. They still go on using the same section and all that. Whereas I had a detailed discussion with Amitabh, and we agreed to provide and calculated number of designs on various girders of the crane, and especially where the span is very big. And we could achieve unexpectedly the result. Let me tell you that when a designer works, as Amitabh mentioned somewhere, that designer is the key. If he want to decide, he should be fearless. He should not be, thinking that something will go wrong. There are standard data available, standard stresses available. Then why things should fail? Earlier, what was happening when I remember early 70s, where the Bucharest steel plant were coming, and that a total Russian design. And this Russian design, Russian design is very heavy. I also remember Pandit Nehru, because we have nothing after our independence, and Pandit Nehru placed an order for a steel plant in Vilai. And I found that this was on the basis of tonnage. The total plant, whether the mill or the crane or the column, the structure, everything was only ₹1.25. I still remember, where the steel was 66 paisa. So the Russian made money. We made we got our steel plant, but then that 50-year or 40-year we can't compare. Russia has made money. We have understood. We learned ourselves. Now we have our own vast data and experience, and so we are surviving because of these suggestions, something which I have suggested. Friends, the next, when we say these are few practical aspects which can be adopted by any engineering workshop, I am sure that yes, this is possible. This is possible. Thank you, and best of luck to everybody. Wonderful. God bless you all. Thank you.
Thank you, Mr. Gupta, for your very, very practical based lecture. And it's definitely.
Thank you.
Okay. Welcome, Mr. Gupta. And now our next speaker is Mr. Pritish Kumar Sen, who was working in Tata Steel and then to Instack. Now he is the editor of Steel Tech, a very, very renowned steel journal. Over to you, Mr. Sen. Please continue.
Thank you, Arnav. Thank you, Mr. Ghosh, Director of GVSNG, and the team for inviting me in this webinar to share my thought. A very good afternoon to all eminent panelists and ladies and gentlemen who are attending the seminar. At the outset, let me congratulate GVSNG for organizing seminar on the optimization. The subject, as you all know, this is use of steelworks in industry and infrastructure, optimization rate and allied parameters with the cost-effective applications and solutions. If you're trying the previous, that webinars they mentioned, Mr. Sai explained, that most of the places where it's a very important point is the cost effectiveness. And the cost effectiveness is coming in many places and this seminar as well. So I do appreciate and congratulate DBA for conducting such seminars on such important topics. While clearly defining the objectives of today's seminar, Mr. Ghosh has also very correctly mentioned about the importance and the use of it, and Mr. Saha and Mr. Ghosh also explained it properly. And my previous panelists, Mr. Joshi, Mr. Mahapatra, Mr. Sarkar, Mr. Amitabh Ghosh also mentioned. He also mentioned about 5% saving could give a 50,000 crore saving. He also mentioned about the field factors. And Mr. Gupta also mentioned very important point of the innovation. And he also explained about the Russian design, which are heavy. Now we could design ourselves. So I shall very briefly mention about the optimization per se, though it may be repetition for many, but it will may be useful for the people who would like to know the basics of optimization when they refer this webinar in future. And then I shall give some of my personal experiences of using this optimization technique in the industry and the benefits achieved. So the basic, if we say what is optimization, in nutshell, you can say the action of making the best or the most effective use of a situation or resources. When you optimize something, you are making it best. That is the one, the optimal, which means the best. Here, what we do is we optimize the objective function, that is fx. Either you maximize or minimize. Therefore, the definition of optimization, I can say it's an act or process or a methodology of making something such as it may be a design, it may be a system, it may be a decision as a fully perfect, functional or effective as possible, and specifically the mathematical procedure such as finding the maximize or minimize the function involving this. Therefore, we find the technique being used extensively from 19th century onwards, be it in a medical application, be it in scientific application, be it in industries, and be it in the world. Okay, because World War II, this was optimal techniques are used extensively. In the 21st century, with many, we can see the use of technical context having to do so in attending the best possible functionally, as it is network optimization, search engine optimization also. So it is of choosing the input that the result, the best possible output for making the best that they can be. So starting with that, here it in our this webinar about the about the optimization of the weight allied characteristics. So therefore, to optimize, as I mentioned earlier, it is either to maximize or minimize, and there are the constraints involved, limits, resources involved. Had there been no limit, no constant on this, there is no question of optimization. For example, if I give a parabola, if you choose a x to find out the largest y, then it is very simple, because we have also used in the statistical calculation when you did the setting the derivatives to parabola to equal to 0. But when it comes to the problem of complex with several variables and many constants, we have to use the special program called optimization algorithms. So, for example, when you choose a warehouse placement where the location to minimize the shipment shortest time, bridge construction to design a bridge to maximize load bearing for a cost-effective solution. It may be for strategy of games, build, order, or maximize army strength. It is a artificial pancreas, that is insulin delivery to minimize the blood sugar derivation. It may be the airplane design wing designed to minimize the weight of the wing while maintaining the strength. It may be a stock market or the application of this to choose the stock portfolios to maximize return based on the predicted performance. It may be chemical reaction, maybe many other things. So it's a very powerful tool for many, many applications. This small sample of optimal use of techniques to improve the quality of the solution is something which can be modeled mathematically. They can be optimized very easily. So there is very important to mathematically model it. Therefore, to summarize, it helps to find out the input that gives the best output, applicable to many disciplines. Now I shall give you example from the industry where I come from. As you know, I am from the steel industry. I spent my time in steel industry. I'll mention about my experience during 90s when I was there in Jamshedpur Steel Plant. So there used to be a huge power shortage those days, and we have to do the load shedding also. You know, whenever there is a time of load shedding comes, the last to shut the load shedding is the hospital, because we never used to give a load shedding to that side. Even OT, these things are enrolled, but as per the directives, even like the township was also not given the thing. So first to do is to do the plant, because but plant is the place where the profit comes, where other things run. Therefore, in a power situation short cases, what we need to do, that we have to do shut down some part of the plant itself. So for the benefit of others, I'll give you the steel company, steel plant, what happens, the raw material comes, that iron ore and coke, it goes to a blast furnace, there's hot metal is produced. After the hot metal, it goes to a steel melting shop, where it is first casted either to bloom, billet, ingot. Earlier ingot used to be there, and then used to go to rolling mills, and then finally going to finishing. And in the finishing mills, they're finishing, as the name says, that finished products are done, such as bars, rods, angles, channels, sheets, etc. So therefore, whenever there is a used to be shortage of power and load shedding is to be done, they used to first close down the finishing mills. And if there need be, then used to put the semi-finished mills, that is rolling mills and the things like that. But what we did, and this is the practice being followed for ages, maybe from 1905 till 92, I was saying, I was mentioning the time, maybe about over 5 decades. So our group is called Plant Engineering and Process Analysis. We used to do a lot of analysis, research, and it was led by a gentleman called Dr. Gopal Sinha, and we used to do the optimization model of the total plant. This is how to use this power. So how to, in the shortage of power, that's a constant resource, how to use it optimally. So purpose of business is, as you all know, to make profit. And our objective was to maximize the net realization. As somebody mentioned, the cost effectiveness, this net realization comes there because once you maximize the net realization, the cost also comes into the picture. So we modeled the complete plan mathematically, starting from blast furnace to finishing mill, covering all rolling mills, steel mills. Even each product wise, meaning that we entered the model, what are the net realization for each product with their parameters such as rolling rate per hour, their power consumption, NR given, etc. We also give the number of constraints, that is availability of power, oxygen, scrap, etc. We ran the model, and the optimized solution given was not the shutting down the finishing mill, but during load shedding, which used to be shut down first. We also we mentioned it gave that you should never shut down the finishing mill. Even if you want to do, you may be throttle semi-finished or throttle, if need be, blast furnace. So therefore, it is a completely total, change of concept. So nobody was willing to listen to us, and it's a very, and nobody want to take the risk also. That time, late Mr. P.N. Rao was the GM works, senior GM works. He sat down with us. He tried to understand what is our model. He somewhat got convinced, but he asked a lot of questions. So finally, he found that, okay, we are telling very sensitive things. We could answer his questions. Like when the human brain, it may be possible for 5-10 parameters, you may understand. But if the variables are more than 5,000, in this case, it was more than 5,000 variables, constants are more than 80, human brain, it is not possible to do so. So finally, nobody could take a decision. It had finally gone to Mr. Rusi Modi. He was the CMD at that time. He gave us a month time for the trial. So the month which was given to us, that month power situation was given worse. We did the shift. We tried to say, depending on, because we had a model, that model was predicting which mill to shut down first, which mill to run, which mill not to run. So we ran that one. You believe me that, when we ran that month with our model, with this one, what it was predicting, and that month, it was the worst situation. It was bad than even the previous months. But after that, we found the profitability of the plant increased by more than 10 crore. So it was a big achievement for the people. And people then Mr. Modi gave us another 3 months. So we ran it. Now it's a part of it. So you can understand what is that, power of that. And we also mentioned, like, even if you put the DG sets, that is diesel generating sets, that it will be recovered within, ROI will be there within 1 year. I remember 6 DG sets were put. We hired your marine engineer, because those, engine used to be like a ship engine. So that gentleman was hired to, and it gave a return within 1 year, it gave back the return. So that is the word that like give the optimization, that, quality of this, that is the one, the power of optimization. And a friend of mine who was there in that group, it is called Paper Cell, Gautam Datta, he went abroad for doing his PhD, and he gave this power model, and he presented that one in that French Edelman Award. That time Dr. Gopal Sinha went there, and this power model received the French Edelman. And that is the one which is the first steel company in the world to get French Edelman Award, was Tata Steel, that time Tisco. And there's the first Indian company to get the French Edelman was Tata Steel. So, that there's a huge benefit and scope. That time I remember we used to run this model in IBM mainframe. And that time we asked for a wax BMS. I remember the cost was 53 lakh. That used to be pretty high, but it was sanctioned. Thereafter, we also extended our model to TCIL. We extended our model to Tubes Division. We extended our model to ISWP. So now it's a part of this thing, what I mean to say here, if the optimization techniques are used, it is very cost effective. It will give back to your benefit. We should use it. And I'll just mention, while I was heading that INSDAG, that Institute of Steel Development Growth, one job was to bridge design, which was done. And there were members from MOT, that is Ministry of Road Transport and Highways, EIL, MECON, SAIL, IIT, BHU, etc. In addition to INSDAG members. In those design, the limit state method was followed, used, and today it will be, listen, Mr. Manas Bose of INSDAC is there, will be giving as a structural engineer, and he also will mention about this while covering his benefits of limit state methods over the working of working stress method in optimization the steel structure. With this brief, I say India, thank you very much. Back
Thank
to
you, Mr. Sen. Thank you. Thank you very much. Yes, people are very much resistant to change. So you implemented it by the help of Mr. Rusi Modi. It was.
yeah, it's
it
a
is
very live
because-
example.
Yeah.
It's a live example. It is an industry live
Yeah.
example. Yes.
Since it was Mr. Rusi Modi, that's why it was possible.
Yeah.
Yeah. Anyway, thank you very much. Our next speaker is Dr. Nishit Ranjan Mandal, ex-professor and head of the department, Ocean Engineering and Naval Architecture, IIT Kharagpur. Over to you, Dr. Mandal. Please take over.
Yeah, thank you very much, Arnabda. Thank you. And thank you, Amitabh. I mean, his continuous persuasion to me that you please say something because of some other obligations, I mean, both family and all that. I said, unfortunately, I don't have time. I'm not a busy man. I'm a retired person, relaxing all the way, but relaxation is now occupying my time. So I could not prepare formally. I said, okay, I'll say something out of my own observations and whatever I have seen throughout my life. Though major part of the life I spent in the academia. However, you can all hear me, I believe. The video has gone, right? Hello?
We can see you and we can hear you as well.
Okay, fine. I can see me. Oh, yes, I am there. Oh, fine. Yeah. So with that pretext, let me thank Avidada once again that he takes up really topics of very much relevance, industrial relevance. I mean, it's not purely theoretical aspects like which generally people are habituated to in any of such technical seminars. So it's of very great relevance, definitely Steelwork. Now, out of the box, what I thought is basically structures what we make. Let it be a bridge structure, a crane structure, or a ship structure. These are everywhere, as rightly put it by many of the speakers, that the designer role is very important. Well, now designer does what happens is he is under real stress from that point of view that he is doing something goes wrong. Well, maybe the first finger to be pointed at will be to the designer, right? So what happens is one of the so-called fear psychosis plays. So the tendency to play safe on the ground, and why that tendency to play safe comes? One reason could be, well, that's very negative, of course. The designer himself is not confident of his own calculations. Second, he is afraid of the uncertainties. Means when you are designing a thing, obviously designing means what? You are doing some calculation. That means some mathematical model you are putting in front of you. Today, people talk about softwares, and that is even more dangerous, which very nicely, probably one of the previous speaker has mentioned. They give such a grim picture. It's not grim, actually. The way the graphics are done for a layman or kind of who doesn't understand, he will think that it will deform so much, it will bend and all that. Those are exaggerated drawings to make you understand. That is the one thing. We'll have to see the absolute values. But those values, again, you will have to take it with a pinch of salt. Why? Because you have to look into for solving that issue, solving that problem, rather, through uses of software, what kind of design, what kind of inputs you have taken. One of the major inputs is the load, and there is the uncertainty. This is not very straightforward that I put 1 ton of load here and 2 tons of load there. and you are analyzing a flat plate. No, there will be a lot of uncertainties. Adding to that, the seismic load uncertainty. So all these uncertainties are involved. So that makes the designer afraid, puts him under a lot of stress, and he tends to play safe by adding more weight to the steel structure, means adding unnecessary higher scantlings, so to say. We use this term scantlings in shipbuilding, that is the dimensional parameters we increase. And next, what I felt is our designs, this is not really true for, I'll say, the bridge designs and probably many other designs, excluding the ship designs. These all are based on codal provisions, right? Based on codal provisions, and which I feel are not necessarily continuously updated, and also suffers from that fear of uncertainty. Whereas I can tell you, gentlemen, here, you may be aware that in shipbuilding, what happens, these structural design aspects, they are guided by so-called a set of rules, which are referred to as classification rules for construction of steel ships, right? There are various classification societies all over the world. Ours is Indian Register of Shipping. So they keep on doing continuous analysis and research, like people have been talking about limit state design and all. Those have been already long back implemented in shipbuilding. There they do probabilistic analysis that whether there would be in the entire lifespan of a ship, given the route, given the possibilities of route variation, whatever, the weather prediction, the ocean condition, the type of cargo, the amount of cargo, what is the probability of suffering some damage or any such thing, probability of flooding. So, because we know there is a term called flooding. If the one part of the ship hull is punctured, the design should be such that the water gets flooded in that particular compartment. That particular compartment gets flooded, but the rest of the compartment should not get flooded. That means the boundary walls, which we name as bulkheads, should not fail. So what the designer should do, that he should design the bulkhead in such a fashion that it can withstand that hydrostatic pressure, right? Very simple. But what we do here is we allow that bulkhead to deflate under that hydrostatic pressure. There will be two ways, that it is such, the hydrostatic pressure is such that no deflection even is allowed. But I allow it to deflect, but not fail. What does that mean? That means I reduce the weight of the bulkhead, I reduce the structural parameters of the bulkhead such that it may deflect, but should not fail. And then when, as it is, the ship is damaged, when we dry dock, we repair that damaged part, also repair the bulkhead. But if I would have done it, designed that it should not deflect even, then unnecessarily weight would have been higher. So these are the areas, right? And also I feel that there is another aspect plays. This came to my mind from the so-called, I have observed, if anybody is from Public Works Department, please do not take any negative view of this. That is, I have seen that if a engineer from, I'm talking about little earlier days, that worked in PWD, so-called, he is given to design the roof slab or the beams of your house, he will invariably design much higher beam depth and structural members, the reinforcement, etc. Why? Because of various other uncertainties they used to face in their works. Poor workmanship, bad material quality, and all those aspects, lack of supervision, right? So they take care by putting extra material, by over-strengthening the structure. So these are some of the things which needs to be definitely the points. I'm now trying to figure out where this higher weight comes. Then also one of the mentioned that non-availability of material, right kind of material. By right kind means, one example I can give you, it's not only adds to the weight of the structure, adds to the production cost, but it may adds to the functionality. It may adversely affect the functionality. Like it happened, you may have heard of the ship MV Harshavardhan, which flies only between Calcutta to Port Blair via Madras Port at times, only in this sheltered on these coastal waters. But it was designed to fly in the deep oceans, but it was never got certification for that. Why? Because it failed in certain stability parameters. Why it failed? Because what happened is, while it was under construction in Mazagon Dockyard in Bombay, the upper part of the ship structure, higher steel weights were put. Why? Because the design steel plates were not available in stock at that time. So with the straightway, I mean, the mechanical engineers who were in charge of that shop that time, they thought, well, if 6mm plate is not available, but 8mm plate is available, put it. Of course, for any layman, it's good from the point of view of strength. Okay, cost will be a little more, but strength. But no, not only cost is becoming a little more, the CG is going higher, and these are the issues. Anyway, so the issues. So how to then what you need to do? Essentially, what you need to do is, as I have said, firstly, that mindset, not only mindset, that fear psychosis should go. The tendency to play safe should go. How it can go? By developing confidence in yourself. The designer should be confident enough that, well, all the parameters I have taken, good background knowledge of the seismic records of the last 100 years, everything I know. So what's the fear? I have to take decision. What is done is, I have seen in my own eyes in my younger days when I worked in a shipyard, even you have designed something, your estimate manager will say, why make it 6mm, make it 8mm. You know, welding, the fillet, 4mm, no, make it 6mm. This is because you are trying to play safe. No, it's not that way. And not always adding weight doesn't help. So anyway, there are various methods like Mr. Mahapatra has already mentioned about various means of reducing weight. And here I just can add to that, one is flat plate construction, then there is a stiffened plate construction, and then in stiffening, you consider along the longitudinal direction, in the transverse direction. So all these can be looked into judiciously, can be used to maybe deviating from the standard practice, but you get a more optimized steel structure. Then now people are talking about sandwich construction. For this construction, we can make sandwich construction where I can use I can get a higher strength to weight ratio. I can also achieve higher stiffness to weight ratio. Because what happens, one aspect is the so-called tensile strength and all that, and the buckling strength. Another is stiffness, because it should not deflect beyond certain permissible limits. So strength to weight ratio as well as stiffness to weight ratio. This can be achieved through sandwich constructions. So there are various such ways and means, and Mr. Kumar, of course, has talked about optimization tools and techniques. That's very fine. That's in a bigger process, or in this thing, it can be done. Amit, I'm already out of time, right? Talking too much? But I have some. Anyway, well, just to finish it, there is another aspect talked about that you keep digital information. That means these days we have the facility of preparing a digital twin of your structure, so that in further analyzing the real life situations to project for the future ones. That way. And finally, well, in some places you can replace steel with some other material like fiber reinforced plastic. Like, I'll give you one very good example where it can be done. that is the highway crash barriers. Highway crash barriers that have high tensile steel, right? So that can be replaced by a fiberglass reinforced composite plastics. It has twofold benefit today. One, it is now with the current ongoing price of steel, it is very much economical. And secondly, it is pilfer proof. Nobody will steal this crash barriers, but if you observe, you will find this crash barriers get stolen often. Anyway, so thank you very much for giving me this opportunity to share some of the random thoughts, I would say. I was not formally prepared.
No.
But
You said it is not well prepared, but we found it most prepared one.
No, I just jotted down, last minute jotted down all I have to say.
No, it's okay.
But
Thank
anyway,
you very much. Thank you very much. And now we request Mr. Manos Mohan Ghosh, consultant INSDAC, to take over with his speech. Mr. Ghosh, please.
Good evening, everybody. I would request Mr. Das to upload my PPT. In the meantime, what we understand is that we are everybody positive regarding optimization. So that is the buzzword, and that creates one thing, that we are not misutilizing any of the material, any of the time, any of the cost, and that is what optimization says. Now, I would like to highlight the certain points regarding design. Where are we at this very moment? How is India geared up for helping us in optimizing our designs from the codal point of view? So next slide, please. Till 1984, we were involved with the method called working stress method. So 1984, it is 38 years ago. And in 2007, we came or we were gifted, that is also 14 years ago, with a new sort of design, which is called the limit state design method. So next one. Why is this change? The working stress method was quite foolproof. So why limit state method? The main objective, obviously, was optimization, not only to its weight, due to all other parameters which has been developed at that time by the help of the research and development being carried out by the premier institutes of India. So what is limit state? Next slide. Limit state, we won't delve deep into it, but the result of advances made in structural steel design. So the advances were incorporated in the code over the years, which has helped. How did it help? In a more rational and reliable estimate of the collapse load. Whenever we design, what are the parameters? Number one parameter is the uncertainties. So if the uncertainties can be calculated statistically and probabilistically, and if it can be converted to certainties, then the results or the solutions will be much more easier. So from working stress method to limit state method, this was a giant step of finding out the range of uncertainties to its extent. Next slide, please. I quoted from the code itself, IS 800-2007, the revised standard. What does it, why has this code been made? The revised standard will enhance, the code itself tells, will enhance the confidence of designers, engineers, contractors, technical institutions, professional bodies, and the industry, and will open a new era in safe and economic construction in steel. So the main motto is safe and economic construction in steel. With this, the limit state method was introduced in the year 2007. Next slide. So now, in fact, 2007, is quite old now. So 14 years back, this was launched. But after that also, there has been much development in structural steel design. So in 14 years gap is a long gap. So in the meantime, Bureau of Indian Standard has brought out another codal provision, which is called the National Building Code in the year 2016, where they have modified this chapter on steel. And even in other way, we can say IS 800-2007 has been modified and has been incorporated in National Building Code 2016. So that is a development. Second development is that this BIS committee, which was discussing on IS 800, has again been formed, and IS 800 is again being taking a new shape, will be out within 1 or 2 years. So there has been a huge development. Now coming to the parameters, you see, when we tell limit state, there are two aspects. One is of strength and one is of serviceability. So the number of parameters under strength are 1, 2, 3, 4, and 5. And also during serviceability, it is 1, 2, 3, 4, and 5. So there are 5 parameters in strength, 5 parameters in serviceability. So let us see what was there during the working stress method. Next slide. So in working stress method, you see strength had only one item, that is permissible stress. The term is working stress design. So the factor important is stress. Under this working stress system, the strength had only one parameter, and the serviceability had only one parameter also. So what we understand, the one parameters which was there in working stress has now been converted into 5 parameters. Or in other way, we are entering into the micro level of designing. Next one. This is the major equilibrium equation for limit state design. The basis is load. If we think of the philosophy of design, load, which is coming as external load, should be resisted by the structure itself, by the material itself, by the configuration itself. So in limit state method, this load and resistance is there, but the load has been multiplied by a load factor, which has been incorporated into a limit state method. So what does it say? That the external loads, what we have conceived, is being multiplied by a factor. Similarly, the resistance is reduced. The resistance, say yield strength of 250 MPa, is never thought that 250 MPa is there in the material. It is reduced by another factor. So these two factors have been included in the basic equation of limit state method. So let us see. One factor is called gamma F, load factor. It is a multiplying factor. If your dead load is 5 ton, we multiply it with a factor, say 1.1. So 5 into 1.1 is your actual design load. And the resistance factor in the other part of the equation, if the resistance is say more than 200 or say 5 ton, so it is thought that the material, the tolerances, and the other parameters which should have been foolproof is not foolproof. So the capacity of that structure is better to be reduced by a certain factor which is there at the denominator. That means the resistance which is coming is reduced by a factor called gamma M. Next one. So here we find two factors in working stress. You see the actual stress, whatever is coming, has no modification. And the permissible stress in the other part, which is called the resistance in limit state method, has a reducing factor. Say, for example, if it is a tension member, then Fy, the yield strength, is reduced by a multiplying factor 0.6. So 0.6 into Fy is the permissible stress. So what happens? the one part of the equation or the stress is being reduced. That is only a factor, so that to take care of the uncertainties. So here we find that the number of factors is 1, whereas in limit state, the general equation gives the number of factors as 2. So 2 options against 1 in limit state. Next one. This is from table 4, which is a huge, we won't discuss it. You see the combinations. In working stress method, the combination of dead load plus live load plus crane load had only one factor, that is 1. Whatever be the load, it is not increased by any other factor, but it is only considered as 1. But in limit state method, it was found that each and every factor or a parameter is to be increased by a certain factor, which is not equal also. Dead load 1.5, live load should be 1.5, and CL is crane load. It is 1.05. So there are certain combinations which have the number of parameters all different, which was not there in working stress method. Whether it is a crane load, whether it is a wind load, whether it is a seismic load, whether it is a no load, the factors were all the same, that is 1. But in limit state method, that was not allowed. According to the importance of the factors of the loads, the factors were changed, and we find of a huge number of factors in this table. So multiple option has been given in limit state method against only one option which was there in working stress method. Next slide. Similarly, the resistance part, which we have spoken, the resistance part has also a number of factors, 1.1, 1.1, 1.25, according to the various conditions. And then when it is connections, the resistance factors are also 1.25 and 1.5. This was not there in working stress method. Working stress method, in fact, had only one factor which told that you can increase the permissible stress by 33% when the dead load plus live load plus wind load, when there is wind load, and when wind load is not the prime load, then the resistance stress or the permissible stress can be increased by 33%. There was no other mention of any sort of factors in working stress method. But in limit state method, we find a plethora of factors which give different values for different conditions of loading. So what does it mean? It means that limit state method is eyeing for a micro level designing concept, which will ultimately yield to optimization. That is what limit state aims. Next one. So here also, the working stress method, the factors were very, very few. Next one, we have already discussed this one. So coming to deflection, if you recall the 1984 version of working stress method, deflection, limiting deflection had only one value, L by 325. That was sacrosanct for loading of a purlin. It was sacrosanct when some other heavy loads, members for heavy loads were also considered. Only for cranes, the deflection pattern was different, and there is no change in the limit state method. In a nutshell, what I mean to say that the options of limit state has 11 number of options, whereas in working stress method, there was only 4 options. Next slide. Similarly, you see the number of options is 6 for limit state method, whereas in working stress, it was only one sacrosanct value, that is L by 325. Next one. Similarly, let's just give this one. It only gives you the example. Next slide, please. So what does it mean? Limit state method, much more detailed, and has searched in the micro level for designing optimize the designs by rationalizing the factors of safety for strength, stress, and factors for deflection under various loading conditions. Economy and optimization is the most important criteria here. In most of the cases, if we have designed, say, for example, 50 cases, 45 cases have been proved that it is much more economic when we use limit state method. There are certain situations where we have found that working stress method is economic rather than limit state method, but that is also in a very small domain. Next one. Let's see some of the uncertainties. This is the World Trade Center. After knowing all the parameters, there was this catastrophe. Next one. This is the uncertainty from in Gujarat, where we knew what is the material. In spite of that, the quality of the material must have been not what was envisaged, and the result is this one. Next one. This is the Tacoma Bridge. You will find it in YouTube, where just after erection, within 1 hour, it's in USA, in 1 hour, the midspan of the bridge just fell down due to one thing called the wind resonance. So next one. Next slide, please. This is a design error of a bridge, also not in India, but also in US. Wherever it was partially constructed, a part just fell down, most probably due to faulty designing. Next. So with this, we end. I just wanted to highlight that limit state method, which is now the in thing in Indian structural steel design, delves into areas where designing can be done in the micro level with the idea of optimizing structural steel design. Thank you very much.
Thank you, Mr. Ghosh. I now invite Mr. Arunabh Dattagupta, who is from ISCO, ex-ISCO, and he is a steel expert. Please come take over, Mr. Dattagupta.
Thank you, Arnab. Good afternoon. At the outset, let me express my deep gratitude for the opportunity given by the organization to share my thoughts. Slide, Amit, please come to slide 2. As Mr. Arnab told, I worked in a steel industry for 38 years, mostly in marketing, and in course of interaction with various project authorities, I have experienced a lot of knowledge on this weight optimization. I would like to share 2 cases here, which I experienced during my service period. Next, the first case is the bridge workshop at Northern Railway, Lucknow. Now, I was a frequent visitor to RDSO in connection with development of some new sections for the wagons. So, in one such meeting, the team of RDSO requested me to meet the chief bridge engineer. In fact, they organized the meeting next day in the office of the chief bridge engineer, where RDSO and rights officials were also there, along with the chief bridge engineer and his team. During this discussion, the chief bridge engineer said that with the emerging trend of high-speed trains coming up in another 5 to 10 years' time, they had changed the design criteria to accommodate this kind of changes. So, accordingly, they asked us to supply ISA 150 by 150, 12 mm, 16 mm, and 20 mm in specific length of 12.5 meter. Act to supply entire quantity in IS 206 to grade B. Next one, please. We expressed our difficulties as it would drastically reduce the yield because there will be generation of short pieces where disposal will be very difficult in the special quality. Railway officials, they said that they won't be able to accommodate because the splicing was not allowed at all. And if the splicing is there, then there has to be external strengthening mechanism which will add weight, net weight of the bridge by 7 to 8%. So they kept on insisting to stick to this specification. So I went back to my plant officials. Next one, please. And discussed with the plant officials, mills and the melting shop and all those things. There was heavy commotion. And finally, it was taken up at the highest level, and the management agreed that though it will be a very kind of a challenging, but the job will be taken up. So we conveyed our acceptance, and railways also helped us in disposal of the short pieces for use in various zonal railways and bridge workshops, and also the wagon industries, wagon repair shops. So after we started supplying, what happened that other zonal bridge workshops started placing their entire order for structural on us. And so to say, we became kind of a captive supplier for them. Next one, please. Amit, next slide, please.
I'm in slide number 5. That's one which you want me to present.
Right.
Okay.
Now, second case is the 4th Brahmaputra Bridge at Bogibil, Dibrugarh. You are all aware that this bridge was 4.9 kilometer long, two-tier rail-cum road bridge. Initially, for this bridge, they had considered ISMC 300/90 as the track base. But later on, to optimize the weight, they changed it to ISMC 250/82 in grade B copper quality and to be supplied in 11.5 meter length. So it was also a very challenging project. Next slide, please. So we accepted the challenge after a lot of discussion at the plant level, and officials of Railway Board also helped us for disposal of the short length pieces by asking the general bridge and wagon repair shops to make use of the short pieces as far as practicable. Next one, please. Now, the situation is something like this. We were having at that point of time the blast furnace, SMS, then ingot route, ingot boom, and billet route for our various sections and TMT bars. It was very difficult to, kind of minimize the yield losses. But there had been the situation, there had been various innovative steps such as adjusting ingot heights. It is very easy to say, but very difficult to do. Change of hot top, and finally, after supplying, we found that we had higher order volume from the railways, and our NSRs also had gone up. Net sales realization had also gone up. So the point I'm trying to say is that most steel producers since then have updated their manufacturing facilities. And in view of this thing, my suggestion is for the designers, for the consultants and the users to demand for more stringent specifications and supply in fixed lengths and closer weight tolerances from the steel producers. Thank you for your patience. Thank you so much.
Thank you, Mr. Dattagupta, for the case studies presented. Many times the case studies help us to understand the things in a better manner. I now hand over the session to Amit to conduct the Q&A session, and then you can hand over the session to Mr. Sudhiranjan Ganguly for vote of thanks.
Yeah, thank you.
Amit, please take over.
Yeah, thank you. Just wanted to address all the attendees. If you have any questions, you can please raise your hand and ask your question to the panelists. They will be, they are here to revert back. We will give you some time, or else we will move to the vote of thanks.
Even the panelists can ask some questions if they have got other speakers.
If there are no attendees to ask any question, can I raise a question? Being outside the steel industry, I just watch few things, and that makes me really interested about how things are going on. So this is not for a specific panelist, it's like to all, whoever thinks it's good to answer. I have seen through all this topic and understand things can be done, but there are underlying risk for which people are like hesitant to go forward and reduce the weight. What are the key takeaway for the industry to overcome this risk? Like, I understand there are a few technical things, but these are already there in the industry, but still people are hesitant to take these steps. So just want to sum up for all the attendees and panelists, what are the key takeaways so that we can overcome this risk?
Amit, I didn't get your queries.
It's not a query, just want to sum up this particular webinar, like about the risk factor. So people understand we can reduce the weight and to optimize things, but still people are hesitant to take these steps. So what are the steps we can take to overcome this risk factor?
I can share my experience.
Yes, please.
On this matter. Long time back, I was also designing stacker reclaimer.
Yeah.
And our main company from which we were co-operating, that was MAN at Nuremberg, Germany. So we were doing the drawing and then going there and getting the approval from them. And I found the designers are very important in that office in Germany. I was also a designer in India, and with no position, you can say, in India. So I asked the person in charge, or the top person in MAN, why your designers are treated as very important person. So he told me that I'm surprised you are asking me this question, because every year my input cost goes up, wages and all this thing goes up, but my selling price is flat. It is not increasing. So who will take care of the gap between the price and the cost? That is my designer. He will make it more cost effective. He will reduce the weight, reduce the power, make it easy the manufacturing process. They are our think tank. If they are not important, who else will be important? So I told them it is not considered in our country that way. Well, then I cannot say on that. This is the main thing I am telling. I am telling in front of Mr. Joshi because NHPC is one company, I must say, the public sector company is complete in all respects. And they have got a very good engineering cell, engineering office. That is why they can control and running the show in-house. So unless that is in-house.
Okay, in that case, I have to chip in.
Yeah, please.
I have to chip in. I think what I understand from Mr. Das' question is that what is the key takeaway from here, from this webinar? Well, the optimization is an integral part of design. Everybody knows that. It will be done. The uncertainty spoke to in the beginning, and Dr. Nishit Ranjan Mandal also spoke later on, that if there are uncertainties in the loading, then probably no designer would like to take a risk. Now, these uncertainties are specific to certain sectors. Like I said, for hydro design, for underground design, they are specific. So let's not put them all in one basket. So wherever loads are certain, wherever material is known that it will perform nicely, and it's a very good, nice process it has undergone through, there's absolutely no reason why designers should be really skeptic and why should they be afraid. The designer only has a skepticism coming into when the loading is not very clear, or the material properties, material metallurgy may be uncertain. Of course, limit state design has been spoken about. Limit state design, in fact, in concrete, it came in 1978. And in fact, in our college time, when I was studying engineering, at that time, limit state was already a part of curriculum in 1978. I think steel design came later on in 2007, as it was projected. But in 1978, concrete design was already limit state design, and all designed in NHPC for last so many years are basically limit state design only. We are not using working sets at all, as far as the concrete is concerned. About steel, which we do not have, it's a vendor-based design. I don't know what kind of processes they are following. But I'm sure that if we have a certain belief that the metallurgy would be okay, the material which is being supplied is really the material which will perform under those circumstances which I have assumed. So there is absolutely no reason why a designer should be afraid of. They are not. That's one part. That is in general the status which is there in the industry. But here I would like to give you one small anecdote. You see, in NHPC design division, there were about 200 designers. We were working together for a number of projects. And there was one gentleman who was working with us, and finally he got an opportunity to go to United States of America. After a number of years, he came back. And naturally, he called me up and said, he wants to have a cup of tea with me and discuss the matters over. So we discussed. Then he told me that in the USA, he was a stormwater drain designer. Stormwater drain designer. That's a specific kind of a sector. So you can't go on designing each and everything if you are a designer. You have to be very, very specific. Unfortunately, in India, I will not talk about NHPC because we were actually specifically working for hydro. But in, let's say, PWDs or municipalities, nothing, not to speak bad about them, but you expect everything from a single person. He should be a road engineer, he should be a stormwater drain designer also, and absolutely there's no quality control of the intellectual quality control. There are no examinations, but elsewhere, I'm told that every designer has to pass an examination after certain years of time to get that kind of license. So these two are the things I wanted to put before you. I think that is the takeaway, if you can call it, that uncertainty is really the culprit. Uncertainty in the loads, I should say, is the culprit. Because as far as the material is concerned, all the processes have been standardized and we can rely upon them. But as far as the loading, particularly geotechnical loading and the seismic loading, wherever it has an interface, probably designer is well placed to have some kind of not exactly a fear, but maybe he would like to be more safe. Thank you very much.
Thanks a lot, Mr. Joshi. Like if we compare with the IT sector here, we do build some kind of prototypes for subject matter experts here. So yeah.
I want to add a little to
sure.
his views. Actually, what you are telling, that why you are hesitant to take a decision and all. This is basically decision making is an art. It's an art. You may be working with a group, you are heading that group, and there are 50 engineers. When you are sure that all the factors have been taken care of, all the odds have been taken care of, so somebody is to take a decision. There may be varieties of opinion and all that. Somebody will no, we can do it. But you take care of all the bad points and good points. And the chief is to take a decision, yes, go for that. These decision-making people, you can count in fingers in any organization. So that is, I think, as because, I was for a pretty long time, I headed that professor project. And I headed the WBPDC also for a long time. So that is the art. So I used to tell all my juniors that when you take a decision, I am here. You will, if you fail, you just take my name. It's my fault. So that sort of confidence, the chief of the project or chief of the organization, he is to infuse that sense of decision making to his juniors. I think that is an art. So that is to be practiced. Okay. Yes.
Thanks a lot, Mr. Joshi, and thanks a lot, Mr. Mahapatra. So I understand. Yeah, thanks for commenting on this. So the subject matter experts and the leadership risk-taking abilities also. Yeah. Thank you.
So finally, we are moving to Mr. Sudhiranjan Ganguly, ex-GRSE and a marine expert, for concluding remarks and vote of thanks. Please take over, Mr. Ganguly.
On behalf of GBS Energy, I have been entrusted with this pleasant task of closing this our webinar. I would thank everyone associated with today's discussion. While
আপনাকে শোনা যাচ্ছে না গাঙ্গুলি দা, Mr. Ganguly, you are not very audible. Come closer to the mic.
Your volume is less, so please speak louder or come to closer to the mic. That's all.
Hello, can you hear me?
Yeah,
That's better.
better.
Okay. Hello. Good evening to everyone. On behalf of GBS Energy, I have been entrusted with the pleasant task of closing this webinar. I would thank everyone associated with today's discussion, while special thanks attributable to the speakers for sharing valuable inputs through excellent presentations, which have enriched the topic of discussion. Obviously, it's a never-ending topic for highlighting various aspects, starting from design specifically, including codes, standards, manufacturing and erection practices, concepts, safety factors, etc., etc. These have all been presented during discussion. Now, it has been indeed a quite interactive session. However, in my opinion, the primary and most important step is perhaps to orient mindset towards the objective of this seminar across all the stakeholders, not only designers, because it is the customers. Sometimes they insist on, oh, heavyweight, very good. It's not all, but many such. So it is necessary to change the mindset across all the stakeholders. Now, I would like to thank especially Mr. Balraj Joshi, who is ex-CMD NHPC, and whose presence is quite encouraging to us. It is GBS Energy's endeavor to propagate selected technical issues to engineering fraternity in India through this platform. And the current one is the 6th seminar since 2019. Special thanks is also due to Mr. Amitabh Ghosh, of course, because he is the driving force of all these successful endeavors. Special thanks to Mr. Ghosh, who is the driving force of all these successful endeavors. Can you hear me?
Yes, we.
Last but
you are
not
loud and
least,
clear.
hello,
Yes, you are loud and clear.
clear?
Yeah.
Last but not least, our thanks to Mr. Amit Das of
Thank you.
Amitech and Mr. Arnab Banerjee for their relentless support to make this seminar successful. Once again, I, on behalf of GBS Energy, like to thank you all for participation by taking time out of your regular schedule. Jai Hind.
So let's end here the session. Thank you once again to everybody. So finally,
Thank you.
we are
Thank you so much.
ending
Thank you,
here.
Arnav. Thank you, Arnav.
Thank you.
Thank you all. Thank you very much.
Thank you all. Thank
Yeah,
you.
this was
Thank you,
enjoyable.
Amit.
It's on time, we can say.
Good. Thanks.
Thank you.
Bye.
Thank you. Bye.
Thank you.
Thank you.
Thank you.
Thank you, Mr. Das. See you soon. Thank you, everyone.
Thank you.
Thanks, Amit.